This is kind of a personal retrospective, and since it's personal, I figured I'd have to have a personal title. So, lucky white male geek seeks disruptive technology. So, I just read last week, somebody wrote a business book about how people underplay the importance of luck in business, and let me tell you, I am all over that. But if there's one thing I bring to the party, it's that I like to look for these underdog technologies that seem to be coming out of nowhere, and latch on them. So that's kind of where how I got to where I am today. That and luck. So I got started with computing in 1967 in 6th grade. It was all punch cards, Fortran, all that good stuff. By the time I hit college, I had quite a bit of experience with a bunch of different systems. And the luck here is my family. My family is very geeky. My dad's an electrical engineer. There are 9 kids, and academic performance was highly valued, and we were very competitive, so we were all geeking out all the time. So I got to go to Princeton. This was lucky. I was a third of 4 brothers to go there. So I didn't even think it was such a big deal. I just went. My first year at Princeton, I got involved with the Unix operating system, which had just escaped from Bell Labs. So that was pretty lucky. And then Princeton was going through this major decision about what kind of time-sharing system to get for the university. And the decision boiled down to getting a big Unix system, which all the geeky guys favored, versus going with an IBM system running virtual machines. And eventually it came down to the IBM system, of course, especially after IBM gave the hardware away for free. But the cool thing here is that because I was involved with Unix, I had this crazy idea. It's like, well, Unix is written in C. Can't we just like port Unix to that virtual machine system? What do I know? And this guy, Eric Schmidt, who is far luckier than I am, being the chairman of Google, he took me seriously and organized a project to do this, coordinating between Princeton and the Computer Center and Bell Labs. And so we started a project to move Unix to the mainframe. Then he graduated, and I was stuck slogging along for a couple of years. So in 1977, I went to interview for a summer job at Bell Labs, because summer jobs at Bell Labs were what the cool kids did. And it turns out that this was right when the Bell Labs guys were looking into porting Unix to basically a baby mainframe, an interdata machine. So what happened was I went to Bell Labs to interview, but I couldn't set up an interview with the Unix guys. I got an interview with some group that was peripherally involved with Unix. And the guy who was running the interview, in order to impress me, brought Ken Thompson to lunch. And Ken and I got talking, and then Ken stole me for the rest of the day. So I got to work with Ken for the summer. So I actually had an account on the famous machine you see here in the Ken and Dennis photo. Then during that summer, a guy from Amdahl called Ken Thompson. Ken had spent some time at Berkeley. There was a guy at Berkeley who moved to Amdahl. And then this other guy from Amdahl calls and asks Ken, do you know anything about this Unix on a mainframe thing? And Ken says, hold on, here's Tom. I was literally sitting across the table from him. So again, pretty damn lucky. So I ended up going out to Amdahl for a few years. We had the first commercially operating Unix system that wasn't on a PDP-11. So in 1982, Sun Microsystems was started. Again, very lucky. I had met Bill Joy a few times through my Unix work. But through my family, I actually had 2 brothers, one working at Xerox PARC and one working at Xerox that was commercializing the Star workstation. So during workstation work, which nobody knew what a workstation was back then. But when the guys at Sun called me up and said, hey, you want to work on workstations? I was like, I'm all over that, especially if they run Unix. So that was very lucky. And I got heavily involved with all the networking and implemented 87 different flavors of network protocols. But really the disruptive technology underneath it all was TCP/IP and Ethernet. The internet cut over to TCP in January of 1983. So Sun was actually using TCP/IP before the internet. Around 1990, there was a big search for fast networking. People had gotten to 100 megabits per second with FDDI. Ethernet was kind of coming, but there was a real bottleneck projected. And I got involved with this ATM networking. Stands for asynchronous transfer mode, or it's the kind of ATM that you only put money into. And that was pretty cool. But eventually it got run over by Ethernet. But based on the ATM stuff in 1994, I left Sun and started Ipsilon Networks, where we invented basically IP switching, which is basically applying the ATM switching hardware to make IP go fast. And the luck here was one of my best friends, who had also been at Amdahl and Sun, had become a venture capitalist. So it was easy for me to get out and get funded. The bad luck was that ATM got killed in this time frame by Ethernet switching. And so we sold it to Nokia, and we pivoted to kind of working with firewalls. And this was a really interesting experience because Nokia had wanted to partner with us, and we knew they had a huge ATM investment because they were doing telco stuff. But it was at the period of time when we knew that the ATM thing was not going to fly, and we needed to pivot to something more IP-based. And so it was this awkward conversation of, you guys really want to do ATM? And it turns out the Nokia guys had figured this out too. They said, no, we don't really want to do ATM. You don't? You don't? And so I was like, oh, perfect. So they bought us. That was great. And we ended up building a firewall business that got up to about $500 million in revenue per year. But no one ever knew about it because it was dwarfed by the rest of Nokia. But the cool thing I learned about startups here is it's all about the team. If you build a great team, it's worth a lot, even if you have to totally pivot and do something else. So around 2001, I retired for the first time, created my little consulting company called Lyon About. And of course the luck there was knowing lots of VCs, so they would pay me to listen to some startup pitch and go, whatever. Disruptive technology was Starbucks and Linux. So I spent a lot of time in this period learning all about Linux and converting from my Unix background. So I flunked out of retirement for the first time and started this company, Netillion. We were going to do distributed shared memory, very much the same as what Scale MP has actually done. And they've started a little bit before us, and they're still holding on in the market. But we were relying on 10 gig Ethernet, and it was much too soon for that. So we folded in August 2005. And really, the moral here is that what should be obvious to any business person is that you really need to start with the market. And I'm a technologist. I've never entered a business thinking about the market. I think about the technology. And that is the textbook, clearly incorrect way to do things. So anyway, Netillion folded at exactly the same time that Nuova Systems was being founded. Nuova, the luck there is that the founders of Nuova were these very famous founders from Cisco, the MPLS team, Mario, Prem, Luca, Sony. They called me up and said, hey, you want to be a co-founder? And I was able to take my whole team from Netillion and form Nuova with them. And then Cisco figured out pretty early on that these guys could recruit anyone they wanted from Cisco. So they had to do a deal with Cisco to stop that happening. So we got a very sweet deal to develop both switches and servers. We were acquired when they entered beta, basically, and that became the basis of the UCS server product line, as well as a bunch of switches. And so you can think of the UCS servers as the last of the gold-plated servers. It was before it became clear that the future of servers was to be totally commoditized. But of course, they're still doing pretty well. 2011, I had my second retirement. I got this really cool house on the coast, or so they tell me. I have a hard time remembering it now. But, and I had to switch to decaf. All right, 2013, my buddy Satya Nishtala, who I had worked with at Sun and Antillion and Nuova, calls me up and says, Tom, you got to look at this big data market. And so we started chatting a bunch, and it became clear that the world was going to change again in a very big way. So we started DriveScale. That's the sequence of names and logos there. You have to change your logo every time you get a new marketing person, you know. And the cool thing about Satya is he knows everybody who's ever touched hardware in Silicon Valley. And through him, we were able to get a seed investment from Foxconn, which was very unusual for them, and put us on the map with the VCs and stuff. And so later on, we got a nice Series A from Pelion Ventures. Carl Ledbetter, our VC, was here earlier this morning. So the rest of this is about DriveScale and what we're doing. So if you look at the big data space, or the hyperconverged space, or a lot of other spaces, people are shifting to these hyperconverged systems where there's storage and server in the same box, right? And people no longer use SAN or NAS or any of that stuff. The storage is with the server. And there's a number of different reasons for that, but basically it's cost. You know, you can get this at 3 cents a gigabyte versus $1 a gigabyte for a SAN system. But the trouble here is that now you have a totally inflexible system. You can't scale CPU and storage separately in any reasonable way. And you're stuck with particular server SKUs that can hold those hard drives. So what we do is we have a server disaggregation technology, which basically uses the in-rack Ethernet switch, 10 gig or better. And boy, it's getting better in a hurry, because 25 gigs is available, 100 gigs pretty much available. And we use that essentially as the I/O bus in the rack. So we can take hard drives out of the servers, put them in dumb industry standard JBODs. And we built a piece of hardware we call the adapter to connect the hard drives to the in-rack Ethernet. So some of you may have heard about Ethernet-based hard drives. This is pretty much a step towards that. So that's kind of the first half of the magic trick, where we saw the lady in half, cut the two pieces. But what it lets us do now is to free up the notion of a cluster from a particular hardware silo. So now all your clusters can share hardware pools. Different clusters can be allocated at whim within the pool. The ratio of hard drives to servers can be whatever you want. And the boundaries between the clusters are movable in software. So if you have one cluster that needs more CPU and another cluster that has CPU, you can just move them. And you can even do that with the storage, although it has to move more slowly. So basically what we've done here is we're doing for clusters as a whole what VMware did for individual servers. It lets you dynamically slice and dice them. It lets you allocate a whole new cluster from existing resources instead of waiting a few months for new hardware. So it's all about flexibility. And we have a curious business model too, in that we absolutely do not sell the servers or the storage or the switches. We just sell you this adapter that makes it possible in our software. And this goes back to what Bruce was saying about sticking to your guns. And that it would actually be a lot easier for us to sell the whole thing, but in the long term it would be a terrible margin business. And in the short, and actually we can be friends with the vendors of all those different pieces. So we're all about smarter data center infrastructure. We kind of view ourselves as the next computer systems company, except we don't need to sell those components, which are commodities. So what's the point of selling hard drives? We're not, the hard drive manufacturer has all the IP, let them sell it. So we manage to scale out hardware, we give you configuration flexibility, and over time we'll have machine learning types of things to help you decide how to flex your clusters, in addition to being able to flex your clusters. And we have product in the RAID booth here, if anyone wants to see it. That's it.
Thank you, Tom. Any questions coming in?
So I work for Intel. So are you partnered with Intel on the system?
No, our stuff is pretty similar with RSA, but ours is a real product already.
Okay, dig away.
Yeah, but we think we can converge over time.